People have studied the night skies for thousands of years, wondering if another world like ours might be out there. After the first planet was discovered outside our solar system, the real search for an Earth-like planet began. Today, the question still remains unanswered, but probably not for long. Join us as we discover how a team of scientists working on the Kepler mission at NASA Ames Research Center are on a quest to find an Earth-sized planet in orbit around a distant star. To give us a better idea of how they hunt for alien worlds, let's meet Bill Barucki, principal investigator of the Kepler mission. Bill, can you tell us a little bit about the Kepler mission and how you hunt for planets and stars?
Sure, I'd be delighted to. Basically, what we have is a telescope in space that orbits the sun, looks at 150,000 stars constantly, looking to see if a planet crosses any of these stars.
And does being outside of the atmosphere help with the observations?
Having the telescope outside the atmosphere is essential to success. Basically, you look through the Earth's atmosphere, it's also got clouds and dust and day-night cycle. In space, you have none of that. So you have 100 times more precision. You can find much smaller planets out in space than you could ever find from a ground-based telescope.
And what do you do with the data once it comes down? How is this different than, say, the Hubble mission?
Hubble takes these wonderful images of various galaxies and whatnot. What we do instead is we send back just the brightness of each of these 150,000 stars. So basically you're looking at the brightness of the star as it changes with time. Is it constant, or does it show dips for planets? So basically it's a search through all this data to find those dips.
Sounds like you've been getting great data.
We're getting absolutely wonderful data. Basically, we're getting data over a huge range of objects. Stars and planets, small planets, large planets, planets together. We're also getting very precise data. Data that's so precise that we can make measurements no one has ever made before. People only dreamed they could make these kinds of measurements.
So you're really star explorers.
Yeah, we're certainly explorers. And we're going to be rewriting the astronomy books on all the stars we're finding and all the planets we're finding as well.
You also see this raining down of points.
To tell us more about what's been going on with the Kepler mission, we're here with Natalie Battaglia, Deputy Science Lead. Natalie, how hard is it to see the planets transiting their stars once the science team gets the processed data?
Planets about the size of a Neptune or a Jupiter, those are really easy to see. Planets the size of an Earth, however, those are really truly hidden in the noise. In order to see those, we have to make use of this very innovative software pipeline that we've spent years developing, and our pipeline is really exceeding our expectations on this front.
What has been some of the real exciting things that you've been able to discover?
The year started off with a bang with the discovery of our first rocky planet, Kepler-10b. We followed right on its heels with the discovery of the Kepler-11 system, where you've got 6 planets packed so close to their parent star. 5 of them are within a radius comparable to Mercury's orbit in our own solar system. So it's something very different than our own solar system, so that was very exciting as well. Recently, the team reported on the discovery of Kepler-16b, a Saturn-sized planet orbiting not 1 but 2 stars. We call this a circumbinary system. Now, we'd seen this before in science fiction. George Lucas depicted Luke Skywalker's home world as a world with 2 suns looming above the horizon. So what was imagined has become reality with the discovery of this planet. At the end of 2011, we announced 2 discoveries. The first was Kepler-22b, a planet about 2.4 times the radius of our own Earth, but lies in that just right temperature region. It's orbiting a star that's almost exactly like our own sun, and it's orbiting out at a 300-day period. The second announcement was Kepler-20e and F, 2 planets orbiting the same star that are likely to have the same kind of composition as Venus and Earth in our own solar system, except they're not at the just right temperature. So you can see that we're zeroing in on the planets that are both Earth-size and in the habitable zone. We're almost there. Kepler has exceeded all of our expectations, yet we still know that our most interesting, most compelling results are yet to come.
What's been the reaction to the Kepler mission in the larger science community?
Kepler has been a game changer in exoplanet science. We are having dialogues now that we didn't have 2 years ago even. The scientific community is going to be working on this database, characterizing these planets for decades to come. What we will end up with is a deeper understanding of the abundance of Earth-sized, potentially habitable worlds in our galaxy.
Thanks for joining us, and you can meet us again on our next Destination Innovation.
To learn more about NASA's Kepler mission, go to www.nasa.gov/Kepler.